Um, my students in Physics 4C class, hello, I hope you do well and everything goes well. Today I am going to do some problems again for you from chapter 18. But before that, I want just to mention before I go over problems, it's in your book, page 18, chapter 18, page 492. So these are in page 492 in your book. Yeah, the topic is some special conditions or cases about first law of thermodynamic. So it's about special cases in first law of thermodynamic. You already know what is the equation of first law of thermodynamic. It is total Q. I went as this equation in your class. The total Q is, let me check the voice. The total Q is change in energy plus work done. So conceptually, this equation tells this. If we give heat for a system, this heat, which is Q, it's doing two things. Number one, it changes its energy, and number two, it's doing work. So this is what I like to write it. The first law of thermodynamic, total heat, which is given for the system, it's doing two things. Number one, it changes its energy. What is this energy? It's internal energy. And it's doing work. Now your book writes as this equation, which it's same. This is easy for me to, say it by conceptual. Here is total change in energy, internal energy of system is how much heat we give minus work done by the system. So that is delta E. Anyway, some special cases that we have. The first of all is fourth. It's called adiabatic. Adiabatic. What is adiabatic means? Adiabatic means is the system is completely what? Insulated. So there is no heat transfer. So delta Q in reality it's zero. So what is adiabatic means? Let me give you one example. The fusion process in nuclear process, fusion, not fission. The fusion temperature, when they make actually energy by fusion, so this will be a future energy generation method, it's fusion. It's a machine, it's called tokamak. Inside that machine, so we oriented electrons, the charged particles, we oriented the plasma by magnetic field. The temperature reaches to 20 million Celsius, 10 million Celsius. But that temperature with its heat, it doesn't comes out. That means is that system, it acts like insulated system. So it doesn't let heat be in exchanging. That it's called adiabatic process. So what is adiabatic process means? Is system is completely insulated, and your book says an adiabatic process is one that occurs so rapidly or occurs in a system that is so well insulated that no transfer of energy as heat occurs. So no transfer of energy. So if Q becomes 0, and if you substitute it in this equation, delta E becomes what? Minus work done on system. The second case, it says constant volume. Of course, when volume is constant, the second one, when volume is constant, correct? We know work is equal what? P delta V. So if volume is constant, then W delta V becomes 0, correct? So work done is 0. That's why we have in constant volume, work is 0. So if instead of W I put 0, instead of W, if we put 0, delta E will be Q. The next one is called closed cycle case. What is closed cycle case? Any cycle that you see, they are closed. They are process A, B, C. You know, I don't know, maybe some of them they are like this. They are process, they are closed process. In the closed process, closed cycle, total energy is 0. Change in internal energy is 0. That's why here we have delta E internal is 0. So if delta E becomes 0, total Q is same as the work done by system. The next case is called free expansion. What is the free expansion? In free expansion, imagine here we have two like containers and they are connected together. Okay, here we do have one cork. Now, I do have a gas inside. At the moment when I remove this, like if I open it, if I open this cork, what I am going to have, all this gas will be expands in the second container, and the pressure in both will be same. This is called free expansion. In the free expansion, pay attention here, it's like adiabatic process, no change in energy. So it is insulated system. There is no heat, no exchanging in heat. And no one is doing work. The system, it doesn't do work. Just what is happening, the volume expands. So Q and W, both they are what? 0. If these are 0, then total internal energy is also 0. So really important, you will see case number 1 has a lot of applications in your homework, and case number 3, which is closed cycle, a lot of applications. Okay, now I'm going to start to do problems for you. I'm going to start from question number 45. Okay, question number 45, what it says. It says a gas within a closed chamber. Okay, so our chamber is closed, undergoes the cycle. So what we see here, cycle is also, it's a cycle. So when it is cycle, When it is cycle, remember, closed cycle, total internal energy is 0. Let's see. Undergoes the cycle shown in pressure versus volume diagram in below figure. So it's from chapter 18, problem number 45. The horizontal scale is set by Vs is equal, this is equal 4 cubic meter. So this is 4 cubic meter. So 0, 1, 2, 3, 4. So this is 1, 2, 3, 4. And here you have pressure 10 Pascal, 20 Pascal, 30 Pascal, and 40 Pascal. Calculate the net energy added to the system as heat during one complete cycle. Pay attention. It says calculate the net energy added to the system as heat during one complete cycle. Okay. Calculate the net energy added to the system as heat. Okay, so we have to find heat. So because it is a closed cycle, so what I am going to have, total internal energy, change in internal energy is 0, and we know that thermodynamics first law, it says it is Q minus W. Delta E is Q minus W. Therefore, if delta E is 0, why delta E is 0? Because it is closed cycle. Okay, this is C. Therefore, if delta E becomes 0, substituted in this equation, Q will be what? Work done. So, it says calculate the net energy added to the system as heat. Okay, so I have to find total what? Q. Total Q in this system. So what can I say? I can say Q total here is equal with Q in the process of AB, correct, plus Q in the process of BC, am I right? Plus Q work done in the process of what? CA. So this is Q total. And because it's closed system, so we can say actually that Q total, in reality, Q total becomes equal Q, it's same as W, so I'm going to write it. I will write the work done in AB, because you know it's pressure and volume. There is no way to find Q by equation of MC delta T or MLF or MLV. No, it's pressure versus volume. So we have to find work, then we can find Q, correct? Yeah. So WAB plus work done in BC plus work done in what? CA. So what I do, I use this in reality. Q, it's same as W in closed cycle. Now I have to work on WAB, WBC, W. So I have to work on WAB, WBC, and also W what? ABBCCA. So I want you please to redo these problems Work on these because this is the only time that you can learn thermodynamics. So don't miss it, please, guys, please. Now I will find, first of all, work done in the path of AB. Okay, remember here we have two methods. One method we can go by a calculus, okay, which we can write it by P dV. It's from initial volume to what? Final volume. So you have to find equation of pressure, because pressure is not constant. Pressure is vary by volume as I go from A to B. One way is that, which I did it in previous homework solutions. I did like that. And the second way is also what? We can go with area under graph, correct? I go with area under graph. You can go by calculus one. Either works. So what I have for area under graph, look guys, area under graph will be this for path of AB, correct? So I do have something like this. This is 10 Pascal. This is 1, 2, 3, 30 Pascal, correct? 1, 2, 3. This is 3 because 1, 2, 3, it's volume, yes. So I can find area under graph. Therefore, W in the path of AB, it's trapezoid. It is a small segment, which is 10, plus the big one, which is 30, add them, times height, divided by 2. The answer will be 40, 20, 20 times 3 will be 60. Is everything metric system? Yes, 60 joules. This is W in path of AB. Now I need to find W in path of BC. In the path of BC, okay, this is much easier. Oops. Oh, come on. In the path of BC, okay. In the path of BC, what do I see? I see volume decreases, but pressure is constant. So I'm going to use this equation actually. P delta V, correct? So it will be work in BC will be so it will be like pressure in BC times it's BC, so it will be VC minus VB. Did you get this? Because second minus first, so delta V in the path of BC. So work done in the path of BC will be pressure. How much is pressure in BC? It's constant. It's 30. What is VC? It's 1. Yes. What is VB? It's 4. So the answer will be minus 90 joules. So in the path of BC, work done on the system is negative. Now let's go to find work done in path of CA. What do you think? Volume A It's same as volume what? See, the volume is constant. Do you agree? So if volume is constant, therefore delta V is equal what? 0. So how much is work done? It's this equation. Everything is here. That one or this one, which is integral. So work done will be 0. Am I right? Therefore, guys, now you need to, after you're done with that, let me go by green color. So I will use this equation. Therefore, Q total, which it says as a given heat for the system, will be summation of each of these. So it will be 60 minus 90 plus 0. The answer is negative 30 joules. So this is same as what? Work done on the system or work done by the system. This is negative 30 joules. And question says, calculate the net energy added to the system as heat. This is what we say. This is our answer. Any questions so far? Please let me know. Email me. So that was question number 45. Now let's go on question number 47. Let me open it in your book. 47. When a system is taken from state I to state F, is it same? Yes. When a system is taken from state I to state F along path of okay. It says when a system is taken from state I to state F. Okay, we have different paths. Here we see this. What color is this? This is red, pink. Let's say red. We have this red path. If we want to go from I to F, we have red path, IBF. That's all. And also I have IAF, but FI, it's reversible. It goes back. When a system is taken from state I to state F along path of IAF, you see the arrows in below figure, Q is equal 50 calorie. So I'm going to write Q IAF, excuse me, so this is path of IF, okay, is 50 calorie. And work, excuse me, is in path of IAF is 20 calorie. Okay, everything is by calorie here, not joules. Along path of IBF, so this is for IAF. What I have for IBF, I'm sorry, I'll be back. Excuse me, guys. I apologize. So, along path of IBF, Q is 36 calorie. So, IBF is 36 calorie. What is work done along path of IBF? What is work done in path of IBF? Okay, what can we say? What do you think? Q in IAF is 50. Work done in IAF is 20. In IBF, Q is 36. Work done in IBF is unknown. Okay, so in part of IBF and IAF, let's write the first law of thermodynamic. Always, always. So first law of thermodynamics. What it says delta E internal is Q minus W. So I'm going to apply this equation for each path. For each path. So what I have for IAF, watch it. For IAF, I can write delta E is Q minus W, correct? So total internal energy will be what? Q is 50, work is 20, answer will be what? 30 calorie. This is internal energy of system. Now, what can I write for IBF? Same thing. For IBF, I can write delta E for IBF is Q IBF, correct? Let's put here IAF, IAF. This is also IAF minus WIBF. Good. Now, what do I see here? You go from IAF or IBF, delta E is constant. Change in internal energy is constant. So here I can say delta E IAF, it's same with delta E what? IBF, which it is 30 calorie. This is my key here. Therefore, I'm going to substitute this 30 equal QIBF is 36. Work done in IBF is unknown. Therefore, they want me to find W. So WIBF will be 36 minus 30 will be 6 calorie here. This is part A. what it says, part B. If W is equal to 13 calories, so that's the equal. Okay, when I copy pasted, something comes like dollar and so if if W is 13 calorie from the return path of Fi, so W in the path of Fi is equal with what? 13 calorie. Okay. What is Q for this path? So what is Q in the path of Fi? What do you think? Again, your equation is this. Delta E is Q minus what? W. Am I right? Remember, internal energy, change in internal energy in one closed system, it is constant. It doesn't change. Your total energy in the system is constant. Therefore, what we have here, delta E, I'm going to substitute it as how much we got. It's 30, correct? It is 30. So 30 equal QFI minus work done in Fi. Let me, let me write this one, delta E in Fi. Therefore, here I will say 30 equal QFI is unknown and WFI is 13. Therefore, Q in the path of Fi will be 43 calorie. Or something is wrong, huh? Okay, here's one thing. Because it goes back from F to I, delta E must be negative. So this coughing is because I drank coffee a couple of minutes ago. Okay, so QFI is 43 calorie now. Work done. Q is delta E. Let me see. Q is delta E. QFI is unknown, right? Yes, delta E is Q minus W. Let me see. Let me check the answer. Delta E is that work done from Fi is F2I. It's 13 calorie. That's right. Okay. This is positive, same. The answer will be 43 calories. Okay, now next section. If internal energy, part C, if E internal in the point I is 10 calorie, what is E internal at point F? So point part C says this: if E internal at point I is 10 and E internal at point F is unknown. Yeah, okay. What can I say? I know that delta E internal overall is E final minus what? E initial. Therefore, what can I say? Delta E internal is constant, it's 30, equal EF minus 10. So my final energy, internal final energy will be 40 calorie. Correct? A, B, C, D. It says path of IB. So they want us to find Q in the path of IB, and part E, they want us to find path of BF. Okay, Q in IB, all right. I have to use this one. I do have Q in the path of IBF. So can I write Q in the path of IBF? Watch it. Total Q in this process from IB to F is Q IB plus what? Q BF, correct? Therefore, QIB will be QIBF minus Q what? BF. Now we do have, so QIB will be QIBF. How much is QIBF? It's 36 minus QBF. Oh, we don't have QBF actually. QBF is in section E. So let me find that one first. QBF, QBF. Okay, in the process of QBF, volume is constant. Volume in BF is constant. Therefore, work done in BF is what? 0, using W equal P dV, P delta V. Work is 0, therefore, when volume is constant, remember here, in constant volume, work is 0. So delta E is same as Q. What's up? Okay, here. So WBF is 0. Therefore, using delta E internal is Q minus W, so it becomes only Q. So I can say total energy in the path of BF, it's same as Q, BF, and we know what is delta E in the path of BF, BF. BF, let me see, will be in the path of BF. We don't have any numbers there, no. Okay, internal energy in the point B is 22, correct? And at the point F, as we found it, it was 40. So it will be EF minus what? EB, sorry, less small b, EB, EF, final minus initial. What is EF? We have it from section C, it's 40. What is EB? We have it from the problem, as it says, internal energy at point B is 22. Therefore, 40 minus 22, the answer will be 18 calorie. Therefore, we can say Q in the path of BF, it's same as, it's equal with 18 calorie. Now, because we found this, here I'm going to substitute instead of BF, 18. Therefore, QIB becomes equal with 18 calorie. 36 minus 18 becomes 18 calorie. This is the solution of problem number 47 in chapter 18. Okay. Now, let's do problem number 49. 48, and then it's 49. 48. Okay. It says as a gas is held within a closed chamber, it passes through the cycle shown in this figure. as a gas is held within a closed chamber, it passes through the cycle shown in this figure. Determine the energy transferred by the system as heat during constant pressure process Ca. If the energy added as heat in the path of AB during constant volume process AB is 20 joules. Let me see. Yeah, so this is index, okay? This is QAB. That means heat in the path of AB. No energy is transferred as heat during adiabatic process BC. So BC is adiabatic process. And the net work done during the cycle is 15 joules. Number 48, it says gas held within a chamber passes through the cycle shown in below figure. Determine the energy transferred by the system as heat during process Ca if the energy added as heat QAB during process AB is 20 joules. No energy is transferred as heat during process BC, and the net work done during the cycle is 15 joules. Gas is held within a chamber. It passes through the cycle shown below this figure. Determine the energy transferred by the system. Okay, so it is cycle. When it is cycle, your delta E internal is what? 0. If it is 0, then Q becomes equal with what? W. All it's here. When it's closed cycle, total energy is 0. So Q becomes equal with what? With W. So they want us to determine energy transferred as heat. So we have to find energy transferred as heat during process Ca. So they want me to find Q in the section in the path of Ca. This is our goal. If energy added as a heat, okay, so Q in the path of AB, it says is 20 joules. Let's verify knowns unknowns. No energy is transferred as heat during adiabatic process. So BC, it is adiabatic process. What is adiabatic process means? Adiabatic process means is Q in the path of BC is equal what? 0. Read question carefully. If the energy added as a heat, QAB is 20 joule. Okay, so this is what question says. And no energy is transferred as heat during adiabatic process BC. So this BC is adiabatic. What is adiabatic means? Q is 0. Watch, it's here. What is adiabatic means? Q is 0. There is no heat exchange. Okay, these are what we got just from the problem. Adiabatic process. And the net work done during the cycle, so total work during the cycle from ABC, total work during the cycle is 15. So this is total work. Okay. Find what? QCA. Oh, good. It's all here. Watch it. Let me write by different color. Guys, can I say the equation tells me W is Q, therefore, can I say Q in the path of CA, watch out, plus Q in the path of AB, plus Q in the path of BC. This is all work done in the system. It's total work from A, B, C. Correct? Which this is equal with what? 15. Now let's substitute. These are easy questions, honestly. So I'm going to substitute QCA plus. What is QAB? It's 20. Just you need to understand what it says. QBC is 0. Okay, equal 15. Therefore, QCA is negative 5 joules or calorie, what it says. Joules. So what is happening in the process CA? The system lose heat. That's why Q is negative. If Q becomes positive, that means the system absorbs heat. So here the system in part of CA volume decreases, so it gives away heat. That's all. Question number 49. It says below figure, let me check it here. Below figure 1840, 41. Yeah, okay, insane. Figure 1842 represents a closed cycle. Oh, this is closed cycle. So what does closed cycle means? Total internal energy of the system. So this is total internal energy of the system is what? 0. Figure 1842 represents a closed cycle for a gas. Okay. The change in internal energy of the gas as it moves from A to C. So this is delta E internal total, okay? But it says, question says, the change in internal energy in the path of the change in internal energy of the gas as it moves from A to C. So it's A, B, C, okay? A, B, C, because you see the arrows is from A, B, C. This is internal energy in the path of ABC is 200 joules. That's not dollar. Sorry, this is negative 200 joules. Okay. What? All right. As it moves from C to D, as it moves from C to D is 180 joules. Okay. Must be transferred to it as a heat. An additional transfer of 80 joules is to as heat is needed as it moves. Yes. Okay. The change in internal energy of the gas as it moves from A to C, which is ABC, is negative 200 joule. As it moves from C to D, from CD is 180 joules. See, write this, please. "180 joules must be transferred to as heat." 180 joules must be transferred as heat. An additional transfer of 80 joules to it as heat is needed as it moves from D to A. D to A. An additional transfer of 80 joules to it as heat is needed as it moves from D to A. So Q in dA is 80 joules. Let me read this section. As it moves from C to D, 180 joules must be transferred to it as heat. Okay. So, what can I see here? This is Q in the path of CD, not energy, not internal energy. So, Q in the path of CD is 180 joules. And this is D. Okay. All right. An additional transfer to, okay. How much work is done on the gas? How much work is done on the gas as it moves from C to D? All right. What we can do? First of all, they want me to find W in CD, correct? So we know one thing that we can write it, work done in path of A, B, C, D, let me write this, is equal with work done, total work in path of AB plus work done in path of BC. I break all sections. Work done in the path of CD, work done in path of DA. So CD is here, watch. Keep it. Now, work done in the path of CD, and also using this equation, we know that if delta E total is 0, because it's cycle, correct? Again, let's go back here. When it is closed cycle, delta E is 0, so Q is equal with W. So this is Q total is equal with W what? Total. I want you to be patient, please. Now, so let's find each section. What is work done? Look, work done in the path of A, B, C, which is same as work done in, this is, W in ABC. W in part of A, B, C. Do we have it? No, but I can find it. Because we have energy. We do have energy of the system. So in the path of, let me see what they want, CD, we do have it actually. Yeah, W in path of, let me see, ABC, we do have delta E in path of ABC. We have Q for DA, C, D, yes. Okay, so let's find work done in each section. Let me see, what can I do? Work done in A, B, C. Work done in A, B, C. Correct? So I can say total energy also is total energy in the path of ABC plus total energy in the path of CD plus total energy in the path of what? ABC, CD, and DA. There you go. So total energy is 0. Why? Because internal energy is 0. We know that. Delta E in the path of ABC, it's negative 200. total energy in the path of CD, we don't have it, correct? And total energy in the path of DA, okay, here. What is work done in the path of DA? In the path of DA, volume is what? Constant. If volume is constant, watch out. If volume is constant, work done in dA is equal with what? 0. Therefore, using the first law of thermodynamics, see, if volume is constant, where is that constant volume? Delta E is equal with what? Q. What I did. Okay. So if volume is constant, work is 0. When work is 0, delta E is what? Minus Q. Correct? Because my equation is this, delta E is Q minus W. So if W becomes 0, sorry, this is positive. Therefore, what I am going to have, delta E in the path of dA, it's same as Q in the path of dA. And we know that, which it is here, 80 joules. That's why this delta E in the path of dA will be what? 80 joules. Therefore, I can find delta E in the path of CD is equal 200 minus 80, answer is 120 joules. This is delta E in the path of CD. Remember, my goal is this, finding work in the path of CD. Now, what can I say? Now I can say delta E in the path of CD is Q in the path of CD minus delta E is 120. QCD, do we have it? Yes, 180. Work done in CD is unknown. Therefore, WCD will be found, will be 60 joules. That's all. Yes, will be 60 joules. And let me check it again. Yes. All right. Let's do this problem. It says a cylindrical copper rod of length of 1.2 meters and cross-sectional area of 4.8 centimeters squared is insulated along its side. The ends are held at a temperature difference of 100 Celsius by having one end in a water-ice mixture and the other in a mixture of boiling water and steam. At what rate is energy conducted by the rod? B. Does the ice melt? So part A, it says at what rate? So you know P is equal P conduction is Ka Th minus Tc divided by what? Th minus Tc divided by L. This will be conductivity or conduction rate. So P for copper is 401. Area must be converted. It's 4.8 times 10 to negative 4 meters square. Th will be one is boiling steam water 100. The other one is ice 0 degrees Celsius. This is degrees Celsius. And then divided by L is 1.2. Which if you do this number, if you do 401 times 4.8 times 100 times 10 to the power of negative, 4 divided by 1.2, you will get 1363, is that right? 401 times 4.8 times 100 times 10 to negative 4 divided by 1.2, sorry, 16.04 watt, correct? Part B. At what rate? Okay. Does the ice melt? At what rate? Melting. You know what? Rate of melting means is how much decreases, you know? Means is how much decreases by time. This is rate of melting means. In other words, do you know what does that mean? Rate means is that quantity divided by what? Time. So it will be delta T. But how much? So when ice gets melt, in reality it's mass change, correct? That's how much ice gets melt. So time by time its mass changes. So this means is rate of melting. Pay attention here. Now, what is that? Watch it. It's melting. So when it is melting, what is the equation? Is it not Q equal MLF? Therefore, what can I do? Can I say if I do Q over T is LF is constant, M over T divide, correct? So can I say delta Q over delta T, which is power. LF is constant. Delta M divided by delta T by calculus, I can say. Yes. Therefore, here power becomes what? LF delta M divided by delta. In calculus, you can write it P is LF dm over dt. Either works. Therefore, rate of melting will be this will be rate of melting will be P divided by what? L. We know P is 16.04. It's same as this. LF, we know it for ice water. It's 33,000 should be. Let me see. Yeah. Here is what? Am I right? So everything is in metric system. Yes, yes, yes. So that's in metric system also. So the answer will be found. 16 divided 3. Oops. It's 4.8 times 10 to negative 5 kilogram, which if you do it divided by 1,000 will be 0.048 grams per second. So every second you have this amount, it gets melted. All right, let's see one more. Okay, I can do this problem and the rest you will do it. So problem number 59. It says in below figure, we have two identical rectangular rods of metal are welded end to end. So that means this, picture A, end to end, like this. With a temperature of T1, here is 0 Celsius on the left and temperature of 100 Celsius on the other side. So here you have, 0 Celsius, here you have what? 100 Celsius. In 2 minutes, 10 joules. So when time is 2 minutes, 10 joules conducted. So P conduction, how much is? 10 joules. So this is in part A, okay? At a constant rate, from the right side to the left side, from right side to the left side. So P transfers from this side to that side. How much time would be required to conduct? Okay, part B, not part B, sorry, for picture B. It says how much time would be required to conduct same conduction, 10 joules. If the rods were welded to, like this picture, side to side, and this temperature is still 100, T1 is 0, okay. So here is comparison, same identical material. We have We have just with two different welding. So we know this equation. P conduction is what? Ka, correct? Th minus T cold divided by L. Okay, because it is a comparison, so I can make this equation. I already explained it to you in physics 4b, even in 4a. We can write P2 over P1, say P is direct proportional with K, with A, with delta T. So I can write it, it's K2, A, oops, K2, A2, delta T2. L is in denominator, so here I'm going to write L1. Then this will be K1, A1, delta T1. See, everything is 1, but L will be opposite. Usually, I don't like it right like that. It's this, P2 over P1, K2 over K1 times A2 over A1 times L1 over L2 times delta T2 over delta T. This is the ratio equation, okay? Now, because we compare everything, let's find what is the power. Then we can find about the time. Let's see how much is conductivity in B. So this is P2, this is P1, okay? So I will say P2 over P1. K, it's same because they are same identical metal. So that's why I'm going to put KK. A2, okay, pay attention here. The area of picture 2, look, this area, this area, the contact area, okay? Do you agree that it's 2 times of this area? So I will say A2 is 2 times A1. So far good? Let's go on length. So I go with green color. Watch it. This is L2. This one is L1. You tell me, what do you see? Is which one? What? L1 is 2 times L2 or L2 is 2 times L1? I think L1 is 2L2. L2 is L2. What about differences in temperature? Same. Therefore, what I get? P2 over P1 is this with this gun, A1 with A1 gun, L2 with L2 gun, it's 4. This is the ratio of power, see? So the power, the conductivity rate, the rate of conduction. So here I can get this, P2 becomes 4P1. Oh, yes. In picture B, learn it, please. If we weld it side to side, then like top to bottom, conductivity changes 4 times. So if you want to have good conductivity, weld your material like this. Shorter is better. Shorter is better, remember. When it's longer, no. Shorter is better with more area, of course, is better. So Now you tell me, guys. Question, it's conceptual here. It says, how long does it take, differences between picture B and picture 1? In picture 1, in figure 1, 10 joules, they get conducted in 2 minutes. So I'm going to make something like this. Watch. 10 joules in 2 minutes. We have this one in high school. No, actually, in elementary school. 10 joules is in 2 minutes. Let me see. 10 joules is in 2 minutes. So this is P1. Then what about P2 will be? Let me see. P2 is 4 times of P1. So your time will be increases or decreases? You tell me. Rate of conductivity here is much, much more. So your time will be decreases. How much? 2 minutes divided by 4. Well, 4 times will be decreases. What is the answer then? 0.5 minutes. I believe it. This is time of conductivity. What question says? Look, how much time would be required to conduct 10 joules? Yes, 0.5 minutes. In picture B. Okay? Alright, guys. I do have a lab time, 2 o'clock. So I want you, please, to work on problem number 61. Work on it. And problem number 63, work on it. Maybe I do them and I will let you know. Okay? Have a good day and work on these problems. I will email you. Bye guys, good luck.